Okay, so this is a stoichiometry sheet that I have posted that you're going to be working through. I did want to go through a few things just to make sure that you know what you're doing. So we're going to look at some of these problems, and I'm going to have you work some of them out on your own. My pencil eraser is not the best, but we'll make do. All right, so remember with stoichiometry, I've made some notes on this paper. We basically have two things that we're using. Molar mass to get you from moles to grams, and that's of the same substance. And then mole ratio, you have to have a balanced equation for that, but that will get you from moles of one thing to moles of another. So that's comparing different substances. Okay, so if we look at this, silver sulfide is a common tarnish on silver objects. What mass of silver sulfide can be made from 1.23 grams of hydrogen sulfide obtained from a rotten egg? The reaction and formation of silver sulfide is given below. So, a lot of times in word problems, they're going to put stuff in there that's not really important. This obtained from a rotten egg is not really important. Sometimes you may see it say something like reacted with excess reactants or something along those lines. It's just extra words that they put in there. It's kind of meant to confuse you. But basically, what you need to look for is what was given to you and what you want. So the mass of silver sulfide was given to you. That means we have grams. It wants to know, not given. The mass of silver sulfide is what we want. What is given to us is the mass of hydrogen sulfide. So we're going from grams of one thing to grams of another. Grams to grams is the longest stoichiometry problem because you have to first convert your given grams into moles. Use the mole ratio to get from moles of your given to moles of what you want to go to. And then you have to use molar mass again to get from moles to grams. So remember I said, if we're using mole ratio, you have to have a balanced equation. All right, so I'm going to work this one out like if we were normally doing it. We'd look and see that there's 2 silver here, 1 there. So if we put a 2 there, you have 2 silver, 2 hydrogen, 2 hydrogen, 1 sulfur, 2 oxygen, 1 oxygen. Okay, so then if we tried to change that oxygen, we have to go all the way back. The easiest thing to do on these, try to double that first one you used. So instead of putting a 2 there, we're going to put a 4 there. So that goes 4 silver. Now we need a 2 here to make this 4 silver, because remember this multiplies through. That also changed the number of sulfur to 2. We have 1 over here, so we're going to put a 2 there. Now that also changed the number of hydrogen to 4. We have 2 here, so we're going to put a 2 there. And that changed our number of oxygen to 2. So now we have 4 hydrogen, 2 sulfur, 2 oxygen, and 2 oxygen. So now we can go ahead and write down our given. The given's the one that just has a number with it. So that's the 1.23 grams of H2S. And we're going to need to get grams of H2S into moles of H2S. That's with molar mass. That's always 1 mole of the substance to how many grams of mass it has. To find that, you're going to add up your atomic masses. Hydrogen's 1.01, and there are 2 of those. So that will be 2.02 plus, we've got sulfur, which sulfur, you can see it, is right here, and that is 32 point, we're just going to say 32. So 34.02. Goes in that one. So if it's diagonal from each other, it can mark out. So grams of hydrogen sulfide mark out. That leaves us with moles of hydrogen sulfide. So now we're going to use our mole ratio to get from moles of hydrogen sulfide. And remember, they have to be diagonal to mark out. So that's why I put the moles of hydrogen sulfide down here. And what we want to go to, I'm sorry, that's not always 1 mole. Moles of hydrogen sulfide to moles of, what we wanted was silver sulfide, and that is Ag2S. So now we're going to look at the equation. H2S had 2. Ag2S had 2. That's the coefficient in front of it for your balanced equation. So whatever the coefficient is, that is how many moles you have for that substance. So both of these were 2. So moles of H2S mark out. And that leaves us with moles of Ag2S. Now we're going to convert moles of Ag2S into grams of Ag2S. That's using molar mass. That's always 1 mole to ever how many grams of the substance that you have. So we're going to find silver is right here. It's 107.87. And then we're going to times that by 2, because we have 2 of them. And then we're going back to sulfur, which we said is 32. So 215.74 plus 32 is 247.74. Okay, the moles of Ag2 mark out. That leaves us with grams. That is what we wanted. This was our given. This is what we wanted. So now all we do is multiply across everything on the top, multiply stuff on the bottom, and then divide it. So we're going to take 1.23 times 2 times 247.74, and that gives us 609.44. And then we're going to divide that by this stuff on the bottom. We got to multiply it out though, so that's why I put it in parentheses. 34.02 times 2. We don't need to do the times 1. So that comes out to be 8.96 grams of Ag2S.